So, any comments or questions? I think you saw two different visions of the future. With ion probes, we need more higher calibration materials to get high precision analyses, and with laser ablation, we're working on mapping and developing high-speed analyses. So we had a question here, comment.
With these laser ablation type of flight instruments,
yes.
You're getting the entire periodic table. How about all the isotopes?
Well, you're getting all the isotopes. The only thing is the precision of the isotopes on that sort of instrument are not great. So you couldn't do, for instance, hafnium isotope. You couldn't do any of the elements for which you need high precision isotope ratio work. You could probably almost certainly do some lead isotope work. But yes, you're measuring every single isotope 30,000 times per second.
At the present time.
What?
The precision is not great at the present.
At the present time, no, no. But
50 years?
50, yeah, I wouldn't, yeah, absolutely. Like Michael said, who knows in 50 years? Who knows in 10 years?
Oh, let's see if this on. It is on. Question for Michael. You kind of alluded to this, talking about with SIMS, the issue of sensitivity factors. And I just wonder if you would comment on where are we in sort of the fundamental understanding of sensitivity factors and matrix effects with SIMS. You know, with EPMA, for instance, we seem to have a pretty good handle on that. But for elemental concentrations, where are we with these sensitivity factors?
Simple, nowhere. We don't have it. If you can't matrix match, you're going to get a wrong number. And wrong number can mean you're 5 or 10% wrong. It can also mean you're a factor 2 or 3 wrong. We haven't solved it. And that's what's crippling it. Bad news. Sorry.
Back here.
So very, very impressive, the detail and that you can extract about the chemical variability in these samples that you've shown.
Yeah.
But what is the framework within which you develop a scientific understanding in order to tell that relates what you observe to the history of the sample? What do you do with these maps?
Well,
and what is the scientific basis for that?
well, I tried to show a couple of examples there. So the first thing you can do is you can pull out a geochemical history. And the second thing you can do is with statistics is you can go in and start doing some very clever things like I didn't have time to show all this, but we've been using it to try and determine, for instance, one of the things we're interested in is the source of these gold-rich pyrite nodules. They're in a gold mining camp. So the question is, did these pyrite-rich nodules break down and feed the gold in the veins, or are they actually enriched by hydrothermal fluids from the veins somehow? And this is one of the things we've been working on, and we can use statistics to show that, in fact, chemically, there is absolutely no, excuse me, there's no similarity between the hydrothermal gold veins and the pyrite in the hydrothermal gold veins and the pyrite in these nodules. So, I mean, there are all sorts of things you can apply. I mean, actually to prove the connections is way more difficult. I think someone had a nice slide that basically said our ability to generate this sort of data is still well ahead of our ability to understand it all. But we have to start by generating it before we can go on to try and understand it. I don't know if that answers your question at all, but
Well, we know that there's a history of some of the instrumentation that we use where actually it was somebody else's money that was causing the developments. I mean, even think about optical microscopes, and the biologists wanted this and that, and yeah. We geologists, we did very well by that. I know that ICPMS is used a lot by environmental scientists of various types, but who else could get involved in funding some of the things that you want to do? What other groups would have an interest in doing something similar enough to what you propose that we could maybe piggyback on them?
Well, laser ablation ICPMS is used in a great many fields. It's certainly used in forensics quite a bit nowadays. It's certainly used in archaeology. It's certainly used in geology. And the big application nowadays is in biomedical. So the biomedical people are using laser ablation ICPMS. They're actually imaging tumors and metal distributions in body parts to see, and doing these experiments where you basically feed people certain elements, and then you like these cancer drugs and that sort of thing, to see, well, is this drug actually getting to the tumor? So you can feed people enriched diets enriched in certain elements, and then they're imaging the tumor to see, well, it actually is that element, is the platinum actually reaching the tumor, and that sort of thing. So the biomed area is actually a huge one nowadays. Geology is probably still, I would say, the major one. We just had the North American workshop on laser ablation was just a couple of weeks ago in Austin, and I would say the majority of the attendants were still geologists. Would you agree, Paul?
Yeah. But in imaging, it's really biomedical which is driving the imaging, and you can see why, right? Just mapping out metals within tissues. The concentration isn't so important to them, it's just the distribution. So this is the work that really, the future with laser ablation, or the near future, I don't know about the far future, is developing this mapping, it seems like. But I just wanted to give Michael 2 minutes. Ion Pro people need to develop reference materials to have their technique to flourish. So what would you like to see happen in the geologic community to develop this in a more organized or rapid fashion?
I had a student come and she said, okay, I want to do chlorine isotopes. I said, well, you have to make the reference material. All right, that'll take 2 weeks. 2 years later, it's about to be published yet. So, I mean, a lot of people don't appreciate what's involved in doing this. So, carefully thought, what are the priorities?
Yeah, the question is does an organization like the MSA, or maybe not the MSA, but organizations like this have a major role to play in helping along something like that? Or right now it's done mainly on an ad hoc basis of individuals, and I myself wonder whether an organization of the scale of the MSA, maybe more in analytical chemistry, needs to be involved in something like that. It just seems too ad hoc to me, the way it's going now.
Yes.
Okay. All right. Okay. Go.
I have a quick question for Simon. You show very beautiful image of that pyrite cube or square, and inside the core is octahedral shape. Okay, so my question is, because the shape causes the trace element, or because of the chemical cause the shape? It's arsenic.
Yeah. No, I know exactly what you're talking about. Yeah, it's not my. You need to ask the mineralogists in here. It's a good question. Yes, so you're right. There is that beautiful sort of rhombic core in that pyrite high in arsenic. I don't know, is there anyone in the... There's actually something else there that I've always wanted to ask a mineralogist. So I think you're referring to this beautiful arsenic-rich core here, yeah. So is there a crystallographer here who can... And my other question is always been, is this beautiful antithetic relationship, so the gold and the tellurium in the core here, which are perfectly antithetically correlated, so there's very odd distribution, and the perfect antithetic... oh, sorry, I got the wrong map. Sorry, the tellurium here and the gold here, this is the ratio. But the perfect antithetic correlation between tellurium and gold.
Thinking for 1 second, pyrite versus marcasite, that's 1 second. Different polymorphs?
Yeah.
Okay, let's just do one more question. And then we...
Yeah, just to bring this back to a practical level, what's the cost of SIMS? Has the cost gone down as the improvements have taken place?
Dream on. The costs keep going up, and the problem is the competition keeps going down. It's capitalism.
So give me a rough figure.
4.5 million. Big one, small one, about 1.5.
Okay. Well, NIST has, you know, the main, for laser ablation, I don't know if you guys use the NIST glasses at all, but for laser ablation, their standards are widely used. For a bigger program, maybe, yeah, perhaps the case.
The USGS is also fairly big into development of standards.
More natural
Yeah.
materials, yeah. Okay, I think we better let the next group go ahead.